Hey guys, we'll be taking one more example on seesaws. So let's see, and I'm sure this would clear your concepts on moments because this is very essential. Let's just make a seesaw here. Let's say this is a seesaw of 10 meters, and it is fixed at this center point, which in this case would be 5 meters. We know that because this entire thing is 10 meters. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright, this is a 10 meter seesaw. Okay. So let's say there's a family in the park, and there's a father, there's a mother, and there's a son. So let's say the father weighs about 300 newtons. The mother weighs about 200 newtons, and the kid weighs about 100 newtons. Alright? So first of all, let's see the scenario. The father is sitting at this point. This is the father. And he's sitting at this point, which is, as we know, a distance of 1, 2, 3, 4, 5. Distance of 5 meters. And he's exerting a downward force, a gravitational force, which is equal to his weight. A force of 300 newtons downwards. Alright? So, first of all, the first question says, if the father is sitting at this position as shown, what is the moment that needs to be produced so as to balance the seesaw? Now this is the question. So as to balance the seesaw, the moment that needs to be produced so as to balance the seesaw. So we know that since only the father is exerting the force here, so this is the only force that is creating the moment right now. So let's find out the moment first. So we can say moment will give us F times t, force times distance, 300 times 5. This gives me 1500 newtons meter. So, and this is, we know that this is in a clockwise direction. So this is a clockwise direction force. Moment, sorry. So, if the first question was, what is the moment that needs to be produced in let's say whatever direction, and we have to specify the direction as well. What is the moment that needs to be produced to balance the seesaw in the case that the father is sitting at this position? So we can see that since this is the moment in the clockwise direction, we would need to produce a moment of 1500 newtons meter in the anti-clockwise direction to balance, or to, let's say, cancel out this moment. So first of all, I would say that it's a 1500 newtons meter in the anti-clockwise direction. Now they tell us that, let's say, the mother is sitting at this point. Alright, let's say the mother is sitting at this point. Let's say at this point. This is the mother sitting at this point. Let's say the mother is sitting at this point. And we know that the mother weighs 200 newtons. So the mother weighs 200 newtons. And the kid weighs 100 newtons. So now the question is that the mother is sitting at this point, 5 meters away from the pivot. This is the pivot here. 5 meters away from the pivot. Find the position of the kid if we need to find out or if we want the seesaw to be in equilibrium. That is the question. So, very easy. Our basic principle of moments tell us the moment clockwise should be equal to moment anti-clockwise, which is, let's say, the sum of moment clockwise equals the sum of moment anti-clockwise. So we can write it. We will have to find out the moments of the two separately. Let's find out the moment of the mother first. The moment of the mother would be F1, let's say this is the first force, times D1, the formula of the moment. This would give me the moment of the mother, the moment that she would be exerting in the anti-clockwise direction. And there is the kid as well. So this, who will be sitting on the left hand side of the pivot, and he will be exerting, wherever he will sit on the left hand side, he will be exerting an anti-clockwise moment in this direction. So we will put it in, sorry. Let's say this is anti-clockwise. I'm really sorry. And this is clockwise. It's the same thing, but I just wrote the anti-clockwise here. So this would take him. He would sit in this direction, somewhere on the left-hand side of the pivot, and he would obviously be exerting a moment in the anti-clockwise direction. So this is the moment of the mother, plus the moment that would be exerted or would be produced by the kid. So we would take it as F2 times D2. His force times his distance, the perpendicular distance from the pivot, would be equal to the force of the dad, which is F3, or the moment of the dad, times D3. His force times his distance. We just calculated this. So simply just substitute in the values. So we can see that F1, if I just write it here, F1 is 200 newtons. This is F1 times, we know that she's sitting 5 meters away. So this is times 5 plus F2, which is the force that the kid would exert. This is 100 newtons times D2, because we are finding the distance that he would sit away from the pivot on the left hand side. This would be equal to 1500 Newton meter. I don't want to change the slide because you would just forget about this. So I want to keep it here. That's why I'm up for the messiness here. So okay, let's calculate it like this. So 5 times 200 would be 1000 plus, let's just write it here. 5 times 200 is 1000 plus 100 times D2. Give me 100 D2 is equal to 1500. Just switch it here. This would give me 100 D2 is equals to 500. And eventually D2 would be equal to 5 meters. Just divide both sides by 100 and you would get D2 is equals to 5 meters. So you can see that to balance the situation, the kid would also have to sit at the 5 meters mark. Only then would the seesaw be in equilibrium. Now, using the same example, the same seesaw here. Let's say the father is sitting at this point. This is our pivot here again. Our pivot here. This is the 5th mark and this is the 10th mark. 6th, 7th, 8th, 9th, and 4, 3, 2, 1, and 0. Alright, let's say the father is sitting here with his weight of 300 newtons. the mother sits here with her weight of 200 newtons. But the kid decides to sit at this point with his weight of 100 newtons. What happens then? The question says, what happens then? What happens to the force, to the moment? Where does the seesaw move? Does it even move? Is it in equilibrium? What happens? So we will have to find out. Let's find out the anti-clockwise moments. So we know that of these forces, if this is the pivot, just imagine that you are fixing this and you are moving this. This would move like this in the anti-clockwise direction, and even this would move like this. So both of these things would make the seesaw move in this direction. So both of these would create anti-clockwise moments. So let's find out the sum. Let's say I'm finding the sum of anti-clockwise moments. This would become F1 D1 plus F2 D2. I'm calling this F1 and I'm calling this F2. So F1 times D1, which is 200 times its distance, perpendicular distance, which is 5, plus F2, which is this force, and its perpendicular distance, 100 times 2 from the pivot, 1, 2. This would be, this is 1000 plus 200, this would be 1200 Newton meter. Let's find out sum of clockwise moment. Since there is only one force here, so that would be the only force producing a clockwise moment. So this would simply be F3 times D3. So this would be 300 times its distance, which is 1500 newtons meter. So we can see that the clockwise moment is greater than the anti-clockwise moment in this case. This means that even if they're sitting in this situation, the seesaw would be moving in the clockwise direction because there is a net clockwise moment, and the seesaw would not be in equilibrium. So this is what happens when something is not in equilibrium. It moves in the direction of the moment that is greater. Let's say if it was the anti-clockwise moment which was greater than the clockwise moment, then it would be moving in this direction. So that is what happens. So I am sure you would be much clearer now about moments, and if you have any problems, just drop down your comments and I'll be looking forward to them. So thanks for watching, guys. Stay tuned to it for more.